Hi students, in this video we are going to cover motion in one dimension. First of all, let's define rest and motion. When a body remains in one position for a long time, it is said to be at rest. The act or process or state of the change in place or position with respect to time and relative to an observer is said to be motion. But a body seems to be at rest with respect to one object but may appear to be in motion with respect to some other objects. For example, a person on a railway platform is at rest, for example, this guy, with respect to another person on the same platform, but he is in motion with reference to a person looking at him from the train. Similarly, a passenger sitting in the train will appear to be at rest to another person. These two will see themselves at rest, but this will see this guy in motion, and this guy will see this guy at rest. So rest and motion terms are relative terms. We should ask with respect to whom. We have many types of motion. The first one is linear motion. It's the motion of an object that moves in a straight line. For example, a moving car, a train moving on a track, the coins tossed in the air, they are all linear motion. Circular motion is the motion of an object that moves at a fixed distance from the fixed point. Here all objects rotate in circular motion. So circular motion is the motion in which the body traverses a circular path. For example, a merry-go-round, a wheel, a spinning ball, or a satellite moving in a circular motion around a planet. Periodic motion is the motion that repeats itself at a regular interval of time. Everybody executing circular motion can be said to be executing periodic motion. For example, the pendulum of a clock, a simple pendulum going back and forth, a vibrating string going up and down, or in a swinging going back and forth. Now define distance and displacement terms. Displacement is the difference between the final and the initial position. It is the change of position in given period of time. It is a vector quantity and its unit is meter. As it is a vector quantity, we have positive and negative displacement units. If the positions are to the right, then the displacement will be positive. If the positions are to the left, then the displacement will be negative. So we find the displacement from this formula. The subtraction from the final position of the initial position will give us the displacement, which is a vector quantity. Let's understand it with an example. Let's find the displacement of the given cars A in from A to B. So the displacement, the final position is B, xB minus xa. xB is equal to minus 20 minus xa, the position A is equal to 80, which is equal to minus 100 meters. In B from A to C, so the final position is C, so I subtract from position C to position A. Position C is 150 minus 80, which is equal to 70 meters. In C, from C to B, the final position is B, so xB minus xc. xB is equal to minus 20 minus C is equal to 850, which is equal to 870 meters. But distance is the length of path covered in given period of time. It is always positive and tells how far something is from something else, but doesn't tell us whether it is to the right or to the left. So it's a scalar quantity. Let's use the diagram to determine the resulting displacement and the distance covered by the scar during these 3 minutes. First, let's find the displacement. My initial position is A and my final position is D. So this distance will give me the displacement, which is equal to the final position minus initial position, which is equal to 840 meters. But in distance covered, first I go from A to B and cover a distance of 880 meters, and then go from B to C and cover a distance of 840 meters, and then go from C to D and cover a distance of 100 meters. So in totally I cover 420 meter distance. A car goes 30 meters to north, 30 meters, and then turns to east and goes 40 meters. The distance covered by the boy is 30 plus 40, which is equal to 70 meters. The displacement, this is the initial and this is the final position. So this line represents the displacement of the boy. From the Pythagorean theorem, the displacement will be equal to, in root square, 40 square plus 30 square, which is equal to 50 meters. A boy walks 20 meters to east and then turns to north and walks 12 meters, then turns to west and walks 4 meters. The distance covered by the boy is 20 plus 12 plus 4, which is equal to 36 meters. For the displacement, let's set the initial and the final positions, and this line represents the displacement. So I draw a perpendicular line and form a triangle. This H has a 12 meter length and this H has a length of 60 meters. So the displacement will be equal to, from root 12 square plus 16 square, which is equal to 20 meters.